Hey everyone, so in this video, I'm going to walk through 6 of the problems from the Exam 1 study guide. So here on my screen, I have the study guide, and for this first problem, we're going to go ahead and walk through number 1 here. For the following observations, plot a scatter diagram on the axes provided below and indicate what kind of relationship, if any, exists between x and y. So for this problem with only 5 data points, you are welcome to just kind of put your little tick marks on the x-axis and on the y-axis and then plot your points and then make any observation you have on any relationship. But in the exam, as well as in the study guide, we do provide this data so you could create your scatter plot in Excel. So I'm going to go ahead and go over to Excel, and here is that data from the study guide. And so to create a scatter plot in Excel, it's actually quite easy. We're just going to highlight our numbers here, and then I'm going to go to my insert ribbon on the top, and I'm going to select scatter plot. So I'm going to do the top left option. And one thing that can be useful to help you see any potential relationship, now it should stand out right away that this does look like a positive linear relationship. As the x values go up, the y value also goes up. So in Windows, you could add a chart element and just add a trend line, which can help you kind of see that positive relationship a little bit easier. If you're on a Mac, you have to do it through the add chart element on the top toolbar. So that is a pretty straightforward question, but I thought what I would do on this video is kind of demonstrate a little bit of the other situations that could occur. So I'm going to go ahead and copy my data here, and I'm going to paste it right here. And I'm going to go ahead and insert another scatter plot. And then I'm going to add my, put it right here, and let's go ahead and add our trend line. But what I want to do here is I'm just going to kind of change the data set a little bit. So we have this first dot is the 2 on the x and 7 on the y. So what if this point was more up here? So let's go ahead and change the y to 18. And so that honestly, just with that one change, I would conclude that there's no relationship with this data. So, so this is a good example. So if the line is kind of going horizontal and flat through the data points, there is no real clear relationship as one goes up, the other goes up. But what I wanted to kind of show though is what a negative relationship might look like. So this dot right here is the 3, 9 data point. So what if we just kind of move that one up to 14? You can see kind of the line is getting like this. So these ones are kind of, it's creating like a little V here. So this is the 5, 17. And so like, what if this was more like 8, and then the 6 one was more like 4? So with a data set like this, we can clearly see that this is a negative relationship. So a negative linear relationship. So as you can see here, 2 different data sets. One of them is going up in a positive direction, and then the other one is the x is going up, our y actually goes down. So that indicates a negative linear relationship. Let's move on to the next problem. So in the next problem, we're going to go ahead and tackle number 2 here, which is develop a frequency distribution and a relative frequency distribution using this data here. And so in the study guide, as well as in the exam, it's going to look relatively similar to this. So you need to complete this table to answer these questions of getting our frequency distribution and our relative frequency distribution. On this video, I'm going to go ahead and do it manually in Excel just to kind of keep things simple. So if I go back to Excel here and I click on the tab, here is that same data points from the study guide, as well as like a table that's been set up for you to input your answers. So in Excel, there are functions that make this a little bit easier. For example, I've done a demonstration in the past using the countifs function. But for this one, we're going to go ahead and keep it simple. And then there'll be some data checks that you could do to make sure that you didn't miss anything. So when we're just counting up these numbers and the frequency that they're occurring, you could miss one. So for our first class, we're looking for employees that have taken sick leave between 10 and 19 hours. So we just need to kind of scan our data set and find the employees that are between 10 and 19. So we have 1 here is 19, 2, 3, and then I missed the one in the second row. So 11. So that's actually 4 people. So I'm gonna go ahead and plug in a 4 there. And then on our second class, this is between 20 and 29. So we have 22, and I'm gonna go ahead and highlight these as I'm going through. So 24, 28, 23, 25, 25 again, 20, 28, 29, 21. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I count 10 there between 20 and 29. That looks to be the most frequently occurring class. Then our between 30 and 39, we have 1, 2, 3, and that's it. So just 3 for that one. And then 40 to 49, we have 1, 2, and that's it. So 2. And then 5 is 50 to 59. That is 1, and that looks to be it. So we just have the 1, and so I'm going to plug in those numbers. So we know from the problem, so if I go back to the problem, it's told us the data set below shows the number of hours of sick leave taken by 20 employees. So if these don't add up to 20, we have an issue. So I could either highlight the numbers, and I see down here in the bottom it says sum of 20. We could also use the auto sum button here and just add them up. Now, the reason why I'm doing the auto sum button here is because this is actually what we need for the relative frequency calculation. So our relative frequency calculation is simply just the frequency over the total. So I'm gonna go ahead and type a formula here, and I'm just gonna say equals, and I'm gonna click on that for the cell I2, and then I'm gonna divide by the 20 in the total. Now, I wanna be able to drag this formula down for my calculation, so I do need to lock this I7 so that it will keep the 20 in the denominator for every row in the table. And so the dollar signs anchors it to make it a fixed reference. So I'm gonna go ahead and do that, and we get 0.2, and now this is just simply dragging this down. So for class 1, it's 0.2, class 2 is 0.5, and etc. Now, in the study guide answers, it shows the math. So for example, 4 over 20. When you are working on the exam, make sure that when you're completing the table, you only input the answers. So the frequency counts as well as the relative frequency proportions. So that really does cover that second question. Let's move on to the next one. So the next one is actually question 2 from chapter 3. And that is doing a weighted calculation. So we've given some data here for 5 different buildings, and we have the price per square foot and the number of square feet of the building. And so we want to calculate the weighted average mean for the price per square foot of these buildings. Now, here's our formula for the weighted calculation. You can see that in the numerator, we're going to sum up the weights times the x values, and then we're going to divide by the sum of the weights. So in this particular problem, we want to weight our calculation by how big the building is. So the number of square feet is going to be our weights. So if I go to Excel, so on Excel, we have this data that's kind of set up nice and for us to work through this calculation. Now, if you do the math on your own for the weighted calculation, that's perfectly fine. You could do it in a calculator and then you could add them up. But I like to use Excel because Excel actually makes a weighted mean quite a more simple calculation to do. So I'm going to go ahead and do a calculation here called weighted. And we saw from the formula that we need to sum up the weights times the x values. So I can do that in my table by simply just saying the x values price per square foot times the number of square feet. So that is the W times X. So this is the summation sign, and so we just need to add them up for every building. So if I drag this formula down, and that calculates the weights times the x for each building, then down here in the bottom, if I click on the auto sum button, we could see that the Greek symbol here as well. That is summing up all of the weights times the x's. So all of a sudden, we actually have our numerator number already. So the only thing we need in order to do our weighted average mean is to sum up the weights. So the weights we know is going to be the square footage of the building. So I could use my auto sum button here. And so now this is now the sum of the weights, or W. And so just to get the weighted average mean, it's simply this going to be that divided by that. And so in Excel, that becomes quite easy to do. So we could just say equals this divided by this. And so we get $61.29 for the weighted average for the price per square foot. So you could see that using Excel allowed us to do this calculation in a faster and a simpler way to get to the final result. All right, let's move to the next one. So on the next one, we are given a set of data for some engineers, and the data is just indicates when these engineers were hired. So this is the X, and we just have 6 months of data. So January, February, March, April, May, June. And so for this particular problem, we're just going to be doing some calculation of some numerical statistics. So we want to do the sample mean, sample variance, sample standard deviation, z-score, and then a question about the population. So let's jump over to the Excel and do some numerical measures. So these also are quite easy to do in Excel as well. You're more than welcome to do them by hand if you would like, but we're going to use Excel. So I'm going to go ahead and set this up real quick. I'm going to have the variance, standard deviation, z. And so our formula in Excel to get the average is going to be equals average, and we're just going to highlight these numbers, and we get 2.833333. For our sample variance, we're going to use the var.s formula, and we're just going to highlight the numbers as well. So we get 4.17 for the variance, and then finally our standard deviation for the sample. So if you saw that, if you do use Excel, be careful. The problem did say that this is a sample. So you want to make sure that you're selecting the standard deviation.s as well as the var.s. You don't want to use the p. If I select standard deviation.s and highlight in numbers, we get 2.04. And then finally, it asks for the z-score for a particular day. So to compute the z-score for the month of May. And so let's go ahead and do that in Excel. So Excel, we could do this two ways. I'm going to do it two ways. So I'm going to do Z in Excel. So standardize is our function. And then our X value is, for May, we want to do 6. Our mean is the 2.83. And then our standard deviation is our 2.04. So you can see how I'm doing this formula by just referencing our prior calculations. So that's where Excel can really help you during the exam, because you can build these, write these formulas, get your answers, and then it can help you with subsequent questions. And so if I do our standardized, we should get 1.55. Now, if you wanted to do the Z the old-fashioned way, we could do that as well. And that's just gonna be the X value minus the mean. And I do need to put my parentheses around that because of PEMDAS. I want to do the subtraction first, and then I need to divide by the standard deviation. So that wraps up that question for our numerical measures. So for chapter 4, we're going to just cover 2 problems here. Okay, so the first one is covering some probability. And we have this San Diego Bicycle Companies, and it shows mountain bikes in 3 different colors, blue, brown, and white, and we have 2 different models. And so it asks you, what is the joint probability that a product manufactured is a YZ99 and a brown? So all we got to do is we got to look at our table and find the number of bikes that meet those two conditions, so the joint conditions. So we have the YZ99 and then the brown, and that's 205. So then that is our numerator to calculate our probability, and our denominator is simply just adding up all of the bikes that were produced. So if I add up these 6 numbers, I'll go ahead and let's bring up a calculator real quick here. So 302 plus 105 plus 200 plus 40 plus 205 plus 130. So that gives us 982. So then our joint probability would simply be 205 divided by 982. And so we get 0.2087. All right, well, let's wrap up this video and do the final problem, which is for Bayes' theorem. So Bayes' theorem is actually another calculation where Excel really makes our life easier. So here's our problem. We have vegetables from a summer harvest that are produced by a food processing plant. The manager has found a case of cans that are not properly sealed. So we want to use Bayes' theorem to identify which line is most likely to be responsible for this mistake. So if I go into Excel and I go to our Bayes' theorem sheet, we have a table here that allows us to more easily calculate our joint probabilities and our revised probabilities. So we know from Bayes' theorem, what we learned in the lecture video, that the joint probability is simply just the cans produced probability times the defective rate. So we're going to go ahead and do A2 times C2, and we'll get 0.02. And so now we can easily calculate the joint probability for each line by just dragging that down. Now our revised probabilities is the joint probability divided by the total probability of a defect. So to get the total probability of a defect, we can simply just sum up our joint probabilities for each of the 3 lines, and we get 0.0725. So now our revised probabilities is going to be the joint probabilities divided by the total probability of a defect. Now what you saw earlier, this is actually almost the same exact calculation where we have our denominator that needs to remain fixed for each of the 3 lines. So I'm going to go ahead and click F4, and I'm going to lock the D and the 5 with our dollar signs and center this 0.276, and then I'm going to go ahead and drag that down. And so now to determine which line is the most likely for causing the defect, we're just looking for the line that has the highest revised probability. So we can see that line 2 has the revised probability of 0.483, and so they're the most likely culprit for the defect. Well, everyone, that wraps up this video on Exam 1 Study Guide, working through 6 of the problems. If you have any other questions, please don't hesitate to reach out.